So we left off talking about disk partitions and how they show up. So we said at the end of that last video that when a new disk is inserted, it'll show up in the file system hierarchy under devices or /dev. Naming conventions again. If it's our first SCSI or SATA hard drive, it'll show up as SDA. If it's the second one, SDB, so forth and so on. Now, each of those disks, in turn, SDA, SDB, can also be can be partitioned or broken up into logical locations, storage locations. So our first partition would be, for example, known as SDA1. Our seventh, like SDB7, refers to the seventh partition on the second drive of our SCSI or SATA drive. So that's how they will be numbered. Okay, we can partition during the install when we're initially installing the system, or we can partition after the install if we have free space on the system. Most of our current Linux file systems are ext4. Now, back up for just a second. Partition is logically dividing our disk space into different storage areas. And then after we divide it up, we need to put a file system on it. We need to tell it how it will store the data. ext4 is a way of storing data. You may have also heard of NTFS. That's a way Windows stores data on its file system. You may have heard of FAT or FAT16, FAT32, HPFS. There's a lot of different ways of storing data, but Linux chooses to use ext4. We might talk more about that in just a minute. We can, as we create a new partition, each partition is assigned or can be assigned a label, which is referred to as a volume label. They're not mandatory for Linux volume, but we can assign it a label, so it's easier for us to refer to instead of saying /dev SDA or whatever it is. We can assign it a label. So we don't do much of that, but okay. So how do we partition? Once we have our drive inserted, what do we actually do? Well, there's a lot of different programs we can use. The one we're going to use in this class is cfdisk. And I'll show you in another video how to use that, but we'll use cfdisk to partition the free space. We'll then run an appropriate mkfs command to format the partition. Remember, I told you a second ago that we have to format or put a file system on that partition, whether it's ext4, ntfs, fat, vfat, whatever it might be. We have to format it. Step 3 would be to create a mount point. Now, a mount point is a location on our file system tree where this partition will be available to us to access. So it's the mkdir command pretty much. And then finally, we'll run the mount command. We'll say mount /dev sdb5 into our test mount directory. And that's it. Then it's mounted. Then we can cd into test mount, and we will really be on that partition. One other note, when we run the mount command, it's not actually, it does mount it, but it doesn't persist. If we were to reboot at that point, then we would lose that mount. So to make a mount persist, there's a file that we can go edit, and this is etc fstab. And if we go look at that, or we will look at that during the assignment, but we can put some values in there to make it mount that file system at boot time. In fact, let me show you an example. Okay, here's an example of my etc fstab on one of my machines, and I have a ton of partitions here. You can see I have SDA5 through SDA24. In fact, I have SDA25 down there somewhere as well. But let's just take a look at this for just a moment. So I've partitioned my disk, let's just say roughly 25 times. And each of these entries, refers to a partition where it's going to be mounted. So that's a directory I created. The type of file system that's on it, so ext4, vfat, ntfs. How we're going to mount it, And we're just going to say just use all the default options. There are different ways of mounting it later on if we want to. And then let's put a 0, 0 here at the end. And here's kind of the definition of each of those fields. Anyway, we don't care about the last two, 0, 0. We'll always just put there. But the file system, the mount point, the type, and the options. One other interesting thing we will see here is this entry. It kind of looks similar. So this is actually the file system. This is where it's going to be mounted to. So this is our root file system. It's an ext4 type. And here's the options that they're using. And they're using 0 and 1. We don't really care about that. But this UUID, let's talk about that for just a second. Why use a UUID? A UUID is just a fancy string that refers to a device instead of dev SDA1. Why would we want to use that? Well, say that you plugged in another disk into your computer and booted up. It probably won't happen, but it's possible that the new disk might be identified as dev SDA, causing the system to look for contents that aren't otherwise there. So a lot of times partitions created during install are identified by a UUID in the etc fstab file. We can do that for any of our file systems. So if I do BLK ID on dev SDA24, it will give me back an identifier that I could alternatively use that in my fstab file. So each of our partitions can also have a UUID to refer to that partition if we want to. There are some examples again of the fstab which you can review. Just one other quick note about partitioning. There's actually two different partitioning schemes available. The first one was the MS-DOS partitioning scheme. This is a legacy partitioning system. It's been around for many, many years. But what it says, and this is important to know because you'll still see it, each drive or device can have up to 4 primary partitions or 3 primary partitions and 1 extended partition. Let's back up for just a second. What that really means is in the early days of computing, really there was the idea of partitioning wasn't there. And then someone decided, and I'm being very loose with this, you can go research it, but they decided, really, if we could have 2 systems on this machine, or if we could segment our data, the different advantages we talked about, it'd be nice. So they came up with this idea of partitioning. And this, anyway, eventually evolved into this MS-DOS partitioning scheme where it says, all right, you can divide your disk 4 times. That was it. That was good for a couple of years until they decided, what if we need to divide it more than 4 times? And so they came up with an advancement or enhancement to that, I guess, which is we can take one of those primary partitions, we can make it an extended partition, and inside of that extended partition, we can make a bunch of logical partitions. Okay. So I said a lot of stuff there, but really what we need to know is if we're using the MS-DOS partitioning scheme, if you want more than 4 partitions on your system, the way you will achieve it is you will assign the first 3 partitions, designate them as primary. The last partition you will designate as an extended partition, and inside of that extended partition, you will have the ability to create many logical partitions. Fancy words, but we're still just partitioning our device. Those questions will probably be on the exam. Primary and the 1 extended partitions are always numbered 1 through 4, like dev SDA1, dev SDA2, dev SDA3, dev SDA4. Logical partitions always number 5 or higher. Now, along with the MS-DOS partitioning scheme, we used what was called the master boot record, the MBR. The MBR was a special segment on your disk, on your hard drive, that stored information about how the disk was laid out, how it was partitioned. So it was the first sector of the first track on the first disk surface. that the BIOS, as it was booting up, your machine was booting up, it would go read this little special section of your disk and figure out how your disks were laid out, how your partitions were laid out. This was used in conjunction with the MS-DOS partition table, or the DOS partition table. The master boot record, MBR, contains a small program that reads the partition table, checks which partition is active, and reads the first sector of that partition. So basically, MBR says go look at figure out how the partitions are laid out, and then go boot the area that's marked bootable and load up my OS. Pretty much. So that's the old way of partitioning. The new way of partitioning is using the GPT, the GNU partition table. I think it's GNU partition table. GUID partition table. I had a brain fart for a second. But really, it's just a different way of partitioning that does away with primary and logical and extended, and everything is just a partition. It gets rid of that terminology. The advantage of using this GUID partition table is it allows for large disks and large partitions, more than 2 terabytes. It allows for an unlimited number of partitions. The DOS partition table, I think you had 3 primary, and then you had 1 extended, and the number of logical partitions, I think, was 64 or 128. I don't know why you'd ever need more than that, but hey, GPT allows you an unlimited number of partitions. There are other advantages for GPT that we don't really care about, but that's pretty much the new way of doing things. If I were to go back and look at this system, let's see what I'm using here. Sudo partid -L, another command we can use to manage partitions is the partid command. And let's see if I can get my password in. There we go. So if I look right here, I'm actually using the MS-DOS partition table. And you can see, okay, the first 3 partitions are designated as primary. I have an extended partition that's 2.5 gigs. And then inside of that, and notice these are all numbers 1 through 4, as we indicated before. Inside of that, I just have a bunch of logical partitions. So this one was MS-DOS. I'll show you a GPT one at some point. Okay, let's pause there.